Hello and welcome. Oh, thanks for coming to my talk at Devox UK. I hope you'll get something from it. I probably learn an awful lot more from my talk as well. So just to set the scene, just to make sure that you're going to try and meet some of your expectations. This is really trying to, if you don't know anything about Clojure, if you've never tried it before, or you're just curious about what the syntax looks like, I'm going to try and give you just like a taste of getting going. Give you some idea about some of the language, how it works, and actually show you that in live execution, so you can actually see what's actually happening. I'm going to use a tool called Lighttable, which is a fairly new development IDE, development editor, that originally was for Clojure, but also has JavaScript and Python and some other languages potentially can be put in there as well. I think Lighttable is a really nice tool to use to help you learn Clojure language. So as we'll see, it'll give you that fast feedback loops. I do have to admit that I don't really use Lighttable as my main tool for Clojure. I still use Emacs, but for those of you who don't want to use Emacs, I think Lighttable is a really nice tool for you to use as well. Has anybody done any Clojure at all? Get out. No. So this is something you will know, some basics. Just want to make sure everybody has the kind of basics. If you want to shout out any kind of suggestions or any code you want to see if it works. Again, I don't claim to be a Clojure expert. I'm more of an enthusiast, but hopefully I can kind of show you how it works and give you a good, real understanding. It doesn't have to be complicated, Clojure. It can be very, very simple. There's more complexity you can go into it if you want to get really into functional programming. That can take a little bit of time. It's like when you first learn object-oriented programming. You can do it, but it takes a few days, weeks, months for you to really get it. You wake up one morning, oh yeah, I understand objects. It's the same with functional programming. I mean, it's fairly easy to write the syntax. It's one of the reasons I like Clojure over some of the other languages, is because the syntax is pretty straightforward, and I find the code pretty readable in the most case. So for me, when I'm not doing it all the time, it's a really nice language I can keep up with, hopefully. Well, you'll find out as we go through this presentation. So this is me. I work for a big company in the cloud called Salesforce, and I've got lots of stuff on GitHub. I've got a website there with all the resources and stuff like that. So most of the material on here is online, so you don't have to worry. If you go to jrocket.co.uk, it's just all on GitHub pages. There's slides, and there'll be, obviously, as it's GitHub, there's also code in repositories as well, so you can take a look at all the code afterwards if you want to. So really, the session is going to be, there aren't really any slides. It's really going to be me coding. There's a few slides, but I'm going to do them inside the tool as well, just because I can. So let's have a look at the demo. Where's it gone? It's all the way up there. So this is Lighttable. When you run it, it basically looks very simple. So it's very lightweight, minimal kind of development environment. And you have things like you can go in and browse files, so you can toggle a workspace and look at trees, and you can look at files. I've got a whole bunch of files open. The one thing you need to do before you actually start doing Clojure in Lighttable is actually, well, usually if you're going to build something, you need to create a project in Clojure. And Lighttable uses the standard way of creating projects in Clojure, and that's with a tool called Leiningen. So Leiningen is a really nice tool. I assume you've heard of Maven. Who likes Maven? One person. 2 people. So it's like Maven in the fact that it will manage all your dependencies, it'll build your project. So it's a build automation tool. One of the main differences between Leiningen and Maven is that Leiningen uses Clojure to define your project rather than using XML. So we all love reading XML, don't we? Especially when it's broken. That's why we have tools to do that. So with Leiningen, you can create a project very simply for Clojure, and all the configuration of that project is written in Clojure itself. It's actually just a big data structure, so even if you don't know Clojure, it's pretty easy to read as well. So before you jump into Lighttable, you would go down to your, where is it gone? Oh, there it is. You go down to your terminal, or you can use some of the other IDs. I've got lining and built-in, so you can create stuff. But you can't actually, I haven't seen you can actually create a lining and project from within Lighttable. So you would still do it without outside. So I'm just going to go into an empty folder, if I can find one. So I would just go line, new. And if there's a template you want to use, you can specify a template. I'm just going to, so you can use app, and then give it a name, DevOps demo app. And then Lining will create a project, a skeleton project for you, basically creating, instead of a pom.xml file, it creates a project.clj file. So it's actually, your project file is a Clojure file and can be read by the Clojure processor. And it's, if we go into this project now, so DevOps, we can see that it creates a project CLJ file and some readmes and just a basic structure, just like a source tree and a testing tree. And is that big enough? I might make it a little bit bigger. There we go. And resources and so on, and place to put your docs. So it's very simple, and the project file is just a very simple structure. So it's basically a list. That's all it is. A list with bits of information in it. So we've got our project, and then we've got things like a description, so we can write a little description about project. So if we want to know what it does, we can link it to a web page by using this URL. So all these are what we call keywords, and they're just a handy way to kind of look up a piece of information, because they essentially point to each other. So we'll see some examples of that. And a keyword can reference not just a simple piece of information, but a more complex piece of information. Here we've got a map. So we've got here a license refers to the name of the license and the URL of the license. So again, this is just a data structure, really, using lists and maps to basically define your project. And one of the most important things, obviously, is your dependencies. So this is all running on top of Java. And so you can use all the Java libraries, you can use all the Clojure libraries you want. Clojure itself is a library that runs on top of the Java virtual machine. So here, what we're doing is just pulling in Clojure version 1.6. So there's no need to actually install Clojure separately. Once you've got Java installed, and I assume most of you have, does anybody not have Java installed? Maybe Dick Wall, because he's doing Scala, but no, you still need Java with that as well. So as long as you've got Java and you've got the Java compiler, you can use Clojure. And there's some other stuff here this is an app just to basically do things like ahead of time compiling and so on. So it's very easy to define a whole bunch of things here just by defining a data structure. So all you really need to know is the name of the project and the dependencies. So the only time you would need to edit this file is if you were going to add more dependencies to your projects. So if you were going to add a testing framework, I shouldn't really touch the screen because it wobbles. If you're going to add a testing framework, you would add this to the dependencies. And you see the dependencies are using these square brackets. And square brackets represent something called a vector. What that really is like you can think of it as an array in Java. It's a little bit more to it than that because it's Clojure, but essentially you can have an array of arrays. So here, each dependency has a name and a version, just like you get in Maven. And so you just have every dependency is in an array, and then all your dependencies are an array of arrays. So this gives you a flavor of one of the approaches of Clojure, and that's to have everything pretty much is data. Like functionality is data, data is data, data is also functionality. Everything's all kind of the same kind of thing. It's this idea of homo iconicity. So you don't need to worry about that straight away, but just have this idea that there's less kind of separation between data and behavior, because data functions as behavior, and all the behavior is defined as a data structure, as it were. So we'll kind of explain that as we go along, hopefully. So once you've got your project, then you can start doing things. I mean, you can actually start doing things without a project if you want to, but if you're actually going to build things, you're going to build a library, you're going to build an app, then it's very easy to set up a project with lining in. And then you just create files and put code, you put Clojure code in those files, and then you can compile it, you can run it, and so on. One of the nice things that Clojure gives you is something called a REPL. Are we familiar with REPLs? No? So if you've used Python or Scala or JavaScript even, they have this idea of REPLs. Clojure REPL is really nice. It's basically a runtime environment where you can type Clojure code in and evaluate it and see what it does. So it's a really nice, fast feedback kind of thing. And this is the one thing that takes you into, this is one thing that Lighttable helps you do as well. It actually has a built-in REPL called an insta-REPL, which helps you kind of see what the code is doing as you're typing it as well. So we'll see that a little bit later on. But if we've got a project here, we can simply do line REPL, and it will fire up a runtime environment, a Clojure environment, so we can type in Clojure code, and we can do some funky stuff with Clojure, make it work. We can call Java if we wanted to, call Java libraries and so on. We can pull in Clojure objects as well. One of the things it's doing, because we're firing up an environment, it's going to check the dependencies. It's going to check that we've got all the dependencies. As you remember, one of our dependencies is actually having Clojure itself, so that's quite an important dependency to have. If we don't have Clojure, then we can't really evaluate anything. So there we go. So we have our environment, and we could develop some Clojure. We could write some code in here, and it would work. You wouldn't want to do very long programs in here, but it's a nice way to quickly get started with your project. It even listens to a port on a certain address, so you could actually run a REPL and connect to it from other places as well. So if you wanted to edit, say you wanted to do something crazy like edit your running code on a server, you could actually have your server running a REPL and connect to that REPL and actually edit your code live in the runtime environment, in the production environment, and change your code if there was a bug there. I'm not saying that's a very good practice, but it's one of the kind of things that REPLs does. It allows you to very easily go in and change the code you're working on. And because Clojure is a very dynamic language, it allows you to do that as well. You could very easily change your code. You can redefine certain things and change them, change the behavior of what it does. So in here, now we can do some fun stuff. We could write some code. So write some very simple code. So we could do things like 1, 2, 3. What's the answer? It's 6. So we can simply add code. It's write code, simple expressions, and it will give us the results. We can do string. Boom, boom, boom. Hello. There we go. So string basically joins two strings together. There we go. And so I could do things in here, and it's a nice way to kind of just very quickly try things out. But what I prefer doing is doing it in a tool. So we have a tool called Lighttable to do this. And just to give you an idea of what Lighttable is. So Clojure is this basically a modern version of Lisp, and gives you this functional paradigm to build in. So as I say, it's a dynamic language, dynamic typing. It all runs on the JVM, so you can interact with Clojure very easily. A function approach. One of the things before we go into code, one of the things you need to remember, what we try and do with functional programming, or one of the things we're trying to do is not change anything, trying to minimize the state changes we're making, because if you change state, it makes it very hard to do concurrency. Makes it harder to actually understand what's going on in your application. Whereas if you do a very stateless program, it's very simple, because one part of the program doesn't affect another part. One little function, one little method, if it's not changing state, nothing else can be affected, so you can run it hundreds of times. So you can have a very parallelized software that you're running. So you can run it over thousands of machines, and you know that nothing is going to conflict with each other. You don't have to worry about threading, you don't have to write any threading code and things like that. So this kind of takes away a lot of the pain of doing concurrent programming, because you're not changing state. So it's not a pure language, Clojure. You can change state. You don't have to learn what monads are to be able to change state either. So it basically uses something called software transactional memory, which is kind of like, I always like to think of it as like a transactional database. So if you want to make a change to a variable in Clojure, you make it what we call an atom in Clojure, and that means that you can't change it unless if somebody else is working with it. So it becomes an atomic commit, essentially, to a database. That's that kind of thing. So if you want to change, say, the number of players in the game, then you make a request to change that in a special way. You're not just sort of adding or using mathematical operations. You're actually making a special request to change it, and then they can update it in this software transactional memory, which makes sure that that player information only gets updated by one thing at a time, and it will queue up those requests to change things so that nothing can interact and interfere with each other. So it's quite a nice, safe way of programming, and it does help simplify a lot of things, because most of your code, 80% of your code, is not going to change state, and there's just a small part of it that does. So it makes it very easier to change things. So I touched on learning the REPL. We've created our first app, and we've run our Clojure code. So let's just get rid of that for a second. Oops, where's it gone? So Lighttable, I've got a whole slide deck on here. I'm not going to cover it because it goes into too much detail. But essentially, rather than have this like code, compile, run, result approach, and we're having to switch between things as well. We're having this idea of this very fast feedback approach, where you can type code in, you can see exactly what it's doing. You get information about the data structures, because Clojure is a big data structure. You can very easily see what you've defined and what you're typing is changing the things that your program is doing. So this is one of the things the nice things about why Lighttable really helps you learn the language. So you got all this. You can use like classic IDEs like Eclipse, and they can do Clojure, but then you have everything kind of spread out into different boxes. Where with the with Lighttable, then you actually can see things straight away, yeah, I'm going to skip through some of this. You can see the code as you're evaluating things. So I can go in and see some code. So here we've got print. So this is a bit of Clojure code, and I can just press Control Enter, and it evaluates it. It doesn't print things out, because print line actually prints something to the console. But if I'm evaluating, say, string, so it does hello world, hello Devox UK. So I can evaluate things in line. I can see exactly what it's doing. If I turn this live button on, then it will evaluate things as I'm typing. String. See, if I just type string, it doesn't do anything, because it gives me an error, and it tells me what the error is. So it's, if I click on the actual error message, it'll expand. I can see exactly why string itself doesn't work. And it's probably because I haven't actually given it any parameters, any arguments. Typo? What did it? Oh, there we go. See, typo. See, even it's that easy to use. You see, that was a cunning plan to see if you were awake after lunch. There we go. So if I do that, then so string by itself does work. That's an interesting fact. See, I learn things every day when I play around with Lighttable. So if you just type string, you get an empty string. If I typed in 4 or 3 even, what would that do? So give me the string 3. So there you go. So you don't have to worry about types so much with Clojure because it's dynamic typing. It still has types because it runs on this thing called the Java virtual machine, which loves types. So it's not a typeless language, but as you're coding, you don't have to be thinking about the types as much. You don't have to be typing in all the type information. It's working out for you, just like Ruby and other languages will work it out for you. Again, you can focus your brain on other things about what is actually my language going to do, what my program going to do. So there's a whole bunch of stuff to kind of help you understand. So let's look at some more Clojure code to help you understand what it does. I'm going to switch that off. I think, yeah. So things like adding. So it's this idea of prefix notation. So instead of having 1 plus 1, you've got plus, and then whatever plus is going to work on. So plus is actually a function in Clojure, and everything that's at the start of a list. So list again is defined by the round brackets. So everything inside of round brackets, that's a list. You're actually defining a data structure in Clojure. So this is a data structure, and the first element of a data structure that's a list in Clojure is always a function. So this is always going to be called as a function. So if this doesn't exist, then that will cause an error. So if I change this to 5, that should cause an error because there's nothing. Oops, switch that on. There's nothing called 5 as a function. Why is it not erroring now? Because so this is not a function anymore. I get a nice big stack trace in here, which kind of would show up a little bit better, but it's a bit squished for space. So it's very easy to kind of see that 5 isn't a function, but then plus is a function. Where's plus gone? And so on. And then, so why have prefix notation? Well, apart from the fact that this is essentially a data structure. This is a tree structure that you would actually create once you compiled a code, compiled and parsed any kind of programming language. It does make things like maths really easy to kind of see the order of things as well. And people complain about things like too many brackets in Clojure, but it does help structure the code very easily for you. And if you remember, this code is a data structure as well, so it does help kind of bring things together so they're much more readable. So it's easier to actually work out what this does because you can start in the inner brackets and say, well, what does if I take away if I have 5 and I take away 6 and then minus 7, what does that give me? Does anybody know? No. And then what's 3 times 4? It's 12. And then so I can add. So I'm adding these things up. So I'm adding 1 and 2, and the result of this, and then the result of that, and then I get 21. So it makes it really easy to kind of see. If you used infix notation, which is what Java sometimes uses, not always, then you'd still need to put brackets around anyway, just to make sure that it was doing the mathematics, the arithmetic in the right kind of order anyway. So there is a reason for all these brackets here. Okay. Then some other interesting stuff you can do with Clojure is you can represent things like a half. So you can represent fractions without having to work out what those fractions are. So, yeah, 1/2 isn't that interesting, but what happens if you do, let's see, 7/22? Is that the way right around? Then if you evaluate that, or is it 22/7? I think it's 22/7, isn't it? 7. So if I wanted to evaluate that, I could actually just put in make that a real number, and it should evaluate it to something that's almost pi, but actually I've discovered that 22/70 isn't exactly pi. That's an interesting fact I came across. So if you represent it as this, this kind of number, one of the problems is that you can lose some of the information. If you put it in a short, then you would actually lose some of the information. By keeping it as a sort of rational number, then you can evaluate it when you need it, and then decide at the time of evaluation how much of this, how many decimal points you actually need. Because you might not need all of them, you might need everything. And Clojure doesn't really care because it just kind of puts everything in long integers anyway. Boom. So if you don't want to evaluate it straight away, you can just keep it as a ratio, and then pass that. You could even pass that as an argument to a function. And yes, good question.
Did you say every list will always have a function as a type?
Yes.
Is that from the point of view of the REPL only, or is that just a Clojure thing across the board? You wouldn't ever just have a list of names, you'd have some kind of function receiving that list.
Yeah, so you can, so is the first item always a function in the list? Yes, but you can just have if I have a list, so if I have a list, okay, 1, 2, 3, 4, 5, then that's going to cause an error. Oops, I missed 5 out, there we go. But if I use something called a quote, then it's basically saying, treat this as a piece of data. And there's actually a function called quote, Q-U-O-T-E. So I can write this as Q-O-T-E. And then wrap that, wrap the list as a parameter to quote. Come on. And then that will pass as well. So quote the tick is just like a shortcut to that. Did I get that right? Yeah, there you go. I've got a lot of code in here. It's slowing down a bit. And so you can just use the little quote kind of as a shortcut to that as well. So that's really, if you want to, if you go to data structure and you want to pass that, just the data structure you don't want. So it's basically saying to the evaluator, to Clojure, when it's passing this, saying, I just want to treat this whole thing as a data structure. I don't want to evaluate the first thing as a function. How are we doing for time? Ooh. 20 minutes left, that was quick. And you can, and one thing I've mentioned already is about data structures having behavior as well. So you can pull out information. So if you've got a vector of 1, 2, 3, so basically an array 1, 2, 3, then the element in position 1, just like arrays in Java, arrays start at 0. I've never quite worked out why they start at 0, but they start at 0. So if you want the item that's in position 1, then it's 0, 1, 2. So position in 1 is 2. So you can basically very easily get information out of data structures because they will give you that behavior that they know what's in themselves. They can be quizzed about what's actually inside themselves. There's some cool ways to do some documentation inside Clojure as well. Inside Lighttable. So if you want to know what something does, because learning the syntax is pretty easy. You've seen about half of the syntax already. So you're halfway there to being able to write your own Clojure. There's a whole range of functions you can use in Clojure as well. And that's what usually takes most of the time to actually learning all the different Clojures. But in Lighttable, if you just click, you right-click and select Show Docs, then it'll give you some inline documentation as well. So here, what's a map? This is not exactly a great example because the docs are minimal. But basically, here we've got a function called map question mark. If a function has a question mark on it, it means it's a predicate. And if you remember from Dick Wall's talk earlier on, a predicate is basically you give it something and it tells you whether it's true or false or not. So basically map here, we're giving it something which just happens to be a map, and it's saying it's true. If we change that to something else, let's see if we change that to be a vector, and then, whoops, where'd it go? There we go. And then evaluate that. Good. Come on. It's not true. Come on, I know it's not true. Update. Come on, remove result. There you go, it's not true. Let's think about it now. There you go, it's false. I knew it was false. Sometimes if you put a lot of code, I've put an awful lot of code in this file, so, and it's on the Insta REPL, so it's trying to evaluate everything, so it does kind of slow it down sometimes, especially, so I'm probably running too many other things on my laptop as well. But there you can see that I'm using a map, using a vector, and it knows that that's not a map. So again, it's very easy for me to understand if I've done something very silly. I could, if I'm using a data structure and I think it's one thing, I can quiz it to see if it's another thing as well. Another funky thing you can do is something called class. Let's actually put it on a different line. So if I have a class of that, so just by typing in the brackets, class is telling me what kind of thing it is. So this is a persistent vector. So that's one of the really big things about why a vector is different from an array. I mean, they look exactly the same. They kind of behave in very similar kind of ways, except the fact that a vector is stateless in the fact that you can't change it. Once you've defined a vector, you can't actually change it. It's immutable. There is ways around that, because what the persistent vector will do is if you want to change it, then it will actually keep the original vector. Say if you have vector with 1, 2, 3, 4, and then you add a fifth element to it, it'll actually create two vectors. So you'll have the original vector, and then the new vector, which is a pointer to the original, and then the new value that you've added. So that if somebody's still working with this original vector, it's not changed. So that, again, another reason why concurrency is a lot simpler in Clojure, because nothing is changing. But then you can basically, we'll look at defining things at the moment. You can basically redefine things to point to the new vector, and then use that as the result if you want to as well. So you're not actually changing your data structure, but you can basically decide where you're going to look at in that. Because you basically you could have a huge, great big long hierarchy of vectors that's the same structure. You've just kind of added things onto it, and then you can decide where you're going to point to it later on. And we touched on this with the ratio, but you can also do things like lazy evaluation. So if we look at a function called inc, inc's going to add something to a value. So we're going to give inc 0, so it's going to start from 0, and then it would, if I just ran this, it would give me 1. But we're going to then use another function called iterate. So we're passing one function, a parameter, an argument, but then we're actually passing this whole thing as an argument to iterate. Because this is a list, so the first thing is evaluated, and this is data, but then inc is a function as well, and it evaluates that. So basically what this will do is iterate by 1 from 0 to infinity. Now, I probably don't want infinity, because it's quite a big number, and it would go on forever, and it would really slow down my machine. So we take that as a whole thing, a whole data structure. This is kind of like a potential list of numbers to infinity, but we're not going to evaluate that just yet. But then we use something called take, which will get the first X number of elements from a data structure that we're going to provide to it. So this function is returning a value that this one's going to use, an output. And this is going to iterate around and generate a whole bunch of numbers infinitely. But we only want the first 10 of those numbers. So rather than having an infinitely long number of integer numbers, then we just take the first 10 and we're done. So essentially, everything, the reason this works is because Clojure, functions in Clojure always return a value. That's one of the reasons why they're called higher order functions or first order functions, because instead of doing something, they actually just return a value. So you can't have a function that doesn't return a value. Even if that value is nil, it's still returning something all the time. So that way you can always pass a function to another function as an argument. So you can pass an if statement as a function to another function, as an argument to another function, because the if statement will generate a value. If statements work a little bit differently in Clojure, but that principle is still the same. If you want to add things to lists, you can use things like conj and cons to basically add things to these data structures. Again, if you just use the list, it will fail. But if you're using the quote, then you can add things to the list as well. And there's lots of different operations on the different data structures to help you add things to that. Otherwise, you can't actually add things to the vectors. You have to use the functions that are specific to the data structure to be able to add it. And let's see. And there's just an even bigger kind of example here, where we're so this is kind of like how Clojure programs kind of evolve. So you basically have here, like we usually start in the sort of the center of things. So we have a range that's going to generate 10 numbers, and then we're going to turn that into a list. And where we go, and just get the even numbers out, and just display all these. So basically, we're taking a range of 10 and reducing it down just to get the even numbers out, and that produces a nice kind of list for us there as well. I'm not sure if I explained that very well, but let's jump into some defining things, because that's probably nicer. So we've seen how to use, and I'm running out of time actually, seen how to use functions. So let's have a look at defining stuff, because there's a lot of things you can use in Clojure, but defining stuff you want to do because you want to write your own code, your own behavior, your own data structures. So you may have noticed these little NS expressions, forms. So just like Java uses packages to basically group bits of functionality together, Clojure has something similar. It basically uses something called a namespace just to group different functionality together. So here I've got a namespace called core, and I've got a namespace called defining, and each of those have got different functions and different data structures in. So if I want to refer to some behavior or data that's in one file, I can refer to it via the namespace that's included, just like I would do with the packaging system in Java as well. So how do we define things? So you can define things very simply, just using def. If you've used things like Ruby, then you'll kind of notice that's very similar to how Ruby does it as well. So basically, I could define something called a person with just a string, or I could do something a bit more complex and say I'm going to define some developer events. I'm going to have just like an array of events, just the names of the events. And again, we're using keywords again, so we can kind of refer to them very easily. And then to expand on that further, a common pattern is to use maps to be able to define data structures as well. So just like a normal map, you've got a key value pair. You've got maps in Clojure, again with the curly brackets, and basically you have a value, so a key and a value. In this case, our value is another map as well. So again, we've got another key and a value here. So we've got a URL for the event, and that is the value to go with the key of Devox UK. And the same with Hack the Tower, we've got URLs there. So it's very easy to kind of build a data structure. And I think one of the challenges when you're first starting is to kind of think about how best to build a data structure that's easy to read and very easy to use. So maps and arrays are usually quite common to use, or you sometimes have maps of arrays or arrays of maps or arrays of arrays or maps of maps and so on. It's very easy, again, to go and build these data structures up and represent stuff. So one of the very basic design philosophies for Clojure is to build a data structure and then have your functions operate on that data structure. So the data structure is quite important. It's not like you're doing getters and setters and doing little things inside all your objects. You've basically got sometimes just one data structure or sort of several data structures in the namespace, and that's what you're working on. It's usually quite easy to actually combine. If you write a bunch of different data structures in one namespace, it's usually easy to combine that into one namespace and then pull it out. That's one of the reasons we use these keywords, because it makes it really easy to pull the information out. So I could get the URL from this devents details data structure by just using the Devox UK keyword. So I think I've got an example of that. 9 minutes. So here we go. So you can actually just type in the names of these things and they'll evaluate to the full data structure. But then if you if you qualify, say, I want to know what the dev event details are, specifically on this keyword, then it'll give you the information on that keyword. So remember, that's the value for that keyword. And so when we basically call this data structure as a function, use the keyword to specify what part of that data structure we want, and it gives us the answer there. Does that make sense? Yeah. Because that's kind of showing us a very different way of kind of thinking about your code and how your code works as well. You don't have to write a getter or a setter kind of thing to get that information out. And so that's defining data structures, but what about defining behavior with 8 minutes left? So you can define your own functions, your own behavior. So we have something called Defin. So rather than using def, we're actually still using def, but if we actually, another way of writing this would be def and then function and then the rest of it as well. So you're actually, Defin is just a shortcut for specifically doing some behavior. And about the only kind of obvious difference immediately is the fact that with a function can take an argument, whereas if you're just defining a thing, it doesn't take an argument itself. So here, we're defining hello world with an argument called name, and so then when we call that, it will basically pass in name, and then it will put together hello, whatever the name is, welcome to the world of Clojure, and output that using print line, which we have somewhere here. And so with foo, again, with similar thing. So we're using string, and basically string will concatenate several strings together. So we got the parameter here. So we call foo with Devox UK string, and so it calls foo, and then string Devox UK hello world, and that's what it outputs. So you can very easily see the results in Lighttable. And if you want to document, I'm sure you all document your code religiously. Yes, Java doc everywhere. Documenting your code in Clojure is very simple. Basically, you just put a string after the name of your function, and you can basically just document what it does, and that will show up when you do the show docs thing in Lighttable. Or if there is also a doc function. 5 minutes left. There is a doc function in Clojure, which again will print out this doc string as well. So there isn't really any excuse for you not to document your code. Showing you some examples there. And you can also do some funky stuff with Java, because we've all heard of Java. Yes, we have, yes. So you can actually call Java. I think it's actually nicer writing some parts of Java in Clojure rather than using Java itself. So does anybody ever do any swing programming anymore? Has anybody ever liked doing swing programming? It's kind of horrible. Clojure makes it a little bit nicer, but it's still easy. There's using something like using a function called do-to is really nice, because basically you can chain all these functions together, which you kind of have to do in swing programming. You have to chain all these functions together. And essentially I can basically evaluate this code, hopefully. If I switch on live, then each time, does that work? There we go. Then it brings up a, where's that gone? Where's it gone? It's hiding it from me. So it'll bring up a, this was working earlier, honest. There we go. Yep. Let's close some of these things down. So basically, it will fire up a panel. There we go. And there we go. There we got some. So this is a, believe it or not, that's a Java frame, a J-frame. It's drawing a line in there. And if I switched live on, then I can go in and I should be able to change the dimensions of this. And it's gone really slow now. There we go. And there we go. It brings up another panel as well, so I can instantly see what it's doing all the time. So I haven't really tried swinging in anger, but it's quite a nice way to kind of see what it's actually doing. Your changes are reflected straight away. If you don't want them reflected, you can switch live off. And let's change that to 50 and 50, and it'll draw the line in a slightly different place. Switch live back on. It should give me another in the window somewhere. Where's it? Oh, I squished it too much. There we go. Oops, that's gone squishy. So I can see my results very, very quickly, very easily. What have I done wrong there? There we go. Oh, there we go. There pop. So I can see the results, and it's moved the line down further on. So that way you get this kind of like very fast feedback loop into what you're developing. So you can kind of know very, very quickly if you've written the right code in the right way to do the right kind of thing, which is hopefully what we all try and do every day. I've got 2 minutes left, so are there any questions? And it's been kind of a bit random. Hopefully it's given you a flavor, a taste of Clojure. There's a lot of good guides out there on the internet that really help you. One of the best things I've found is something called For Clojure, which is for Clojure. There we go, forclojure.com. And basically, these are just little exercises that get you going onto Clojure. And they start from the really easy ones to some more complicated ones. And so basically, it gives you intro to strings, talks about conj, like vectors, intro to sets, intro to maps, and so on. Beep, 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 beep. Oh, there we go. That's me. It's one of the ways that a lot of people kind of start learning there. And you can basically, there's also something called Clojure cones, which I didn't get a chance to show yet. Cones. And again, these are another exercises, and basically they give you a gap to fill in, and you can run them either by lining in or by copying them into Lighttable, and basically give you little Clojure bits, and you have to fill in the blanks or the underscores, and then you can evaluate that. So I usually copy this into, except for the meditations, just copy that into Lighttable, and then you can kind of try it out and instantly see as you're typing what it's actually doing, and whether you've actually understood how Clojure works as well. Okay, my time is up. Hopefully you'll stick around for Dave's talk on Clojure. He'll probably give you a much more sensible kind of view of Clojure as well, give you more experience into the language. It is a really great language, so I hope you've given you a taste and some excitement about going and learning it. Thank you very much.